All right, here are solutions to our first perfect problem for Math 251. The first thing you're supposed to do is sketch the graph of this function and its tangent line at x equals 1. And I told you to make that pretty big, zoom in pretty close so that you can see this thing. Lots of different ways you can do this. You can graph this on your calculator, or if you just know where these points are. Or should I do that? Maybe I'll do that down at the bottom. And actually, I want to make it fairly neat, so instead of having you watch me make this, I'll pause this video. Okay, so I have this graph right here. It's not the prettiest graph in the world, but this is the graph of f of x equals x minus 2 squared plus 1. It's our standard parabola, shifted 2 units to the right and 1 unit up. I highlighted some points on here that might be helpful to reference to keep things neat. It should be symmetric. It's not exactly symmetric because I'm not a great artist, but it's close enough, hopefully, for our purposes. So, okay, the first step says sketch the graph of f and its tangent line at x equals 1. So x equals 1 is right here. Here's the point on the graph where x equals 1. And what I want to do is draw a line that goes through this point and just kind of is tangent to my graph at that point. So maybe it would look kind of like this. It's about as close as I can come. Yours doesn't have to look exactly like this, but that's my best approximation of what a tangent line would look like. So step 1, sketch the graph of f and its tangent line at x equals 1. It'll help to have a very large graph that is zoomed in pretty close. Let the x values go from 0 to 4 perhaps. Fine. Calculate the slope of the secant line. Calculate from x equals 1 to x equals 1.001. And use that to estimate the slope of the tangent line that you drew in step 1. Okay. So for part 2 here, I know that the slope of the secant line is given by the difference in the two y coordinates over the difference in the two x coordinates. And to figure out the two y coordinates, what I do is I take, well, maybe I'll write these down here. x1, I could call this guy, which is at 1, and the corresponding y value here is 2. x2 is given to me to be 1 point, how many zeros? 2 of them? 2 of them with the 1. So to find the corresponding y value for that, I can take 1.001 and subtract 2 from it, and then square it, and then add 1. That sounds like something that a calculator will help with. So let's do that. I got 1.001, I think is what I was supposed to start with. Subtract 2, square that thing, and then add 1 to it. And what I get is 1.2 9s and 8, 2 zeros and a 1. 1.9, 2 9s and 8, 1 0 and a 1. Is that what I said? God, why can I not remember 2 zeros and a 1? There we go. That's what I came up with right there. So if I plug in all these numbers, I get 1.998001 minus 2 divided by 1.001 minus 1, which I guess I should be able to do that in my head, but I'm not going to. I'm going to take that number and I'm going to subtract 2 from it, and that gives me this. And then I want to divide that by this difference, which is 0.001, which just means move the decimal place 2 spots to the right, and I got negative 1.999. I think that's all I need my calculator for. So this is equal to negative 1.999. So in part 2, I was supposed to calculate the slope of the secant line and use that to estimate the slope of the tangent line that I drew in step 1. M tangent is approximately negative 2. In fact, as we'll see, it's exactly negative 2. But using this method, all we can do is approximate it. So here's step 1, there's step 2. Step 3 says label a point on this function at approximately x equals 1.5 with an a. So here's where x is about 1.5, somewhere right around in there. Call that guy a. We'll refer to the x value of the point A as x, so its y value is x minus 2 squared plus 1, right? To find the y value, you put the x value into this function, see what comes out. If you put x's in, that's what comes out. So this point A is equal to x, and then x minus 2 squared plus 1. So those are the coordinates of A. I guess that's all I was supposed to do on that point, is put this dot right here. Pretty easy step. Step 4, come up with an expression that represents the slope of the secant line just like I did before, except now not between 1 and 1.001. between 1 and x. Okay. So I have that m secant is still equal to the difference in the y values over the difference in the x values. So if I make this x1, y1, and now x2 is x, to say that should, yeah, x2 is x, and y2 is x minus 2 squared plus 1, I can take y2, which is x minus 2 squared plus 1, and subtract y1, which is 2, and divide that by x2, which is 1. No, that's not true. x2 is x. Maybe I should have written this down here. x1 equals 1, y1 equals 2, x2 equals x, y2 equals x minus 2 squared plus 1. So now I'm plugging these in. Here's the y2, there's the y1, here's the x2, there's the x1. Here's an expression that represents the slope of the secant line. Come up with an expression that represents the slope of the secant line. Done. As we'll see in 2.6, to calculate the slope of the tangent line at x equals 1, we can find the limit as x approaches 1 of the expression that you came up with in step 4. So what it's saying is to calculate the slope of this blue line right here, I think about the slope of the tangent line, maybe between the blue point and the red point, as the red point gets really, really close to the blue point, mathematically, as x approaches 1. So briefly explain why this makes sense. I think maybe I just did that the secant line gets really, really close to the tangent line as this red point gets really, really close to this blue point. Then calculate this limit using the methods of 2.3 to check your answer from step 2 above. What this is saying, what am I up to, step 5? Step 5 says figure out the limit as x approaches 1. The limit as x approaches 1 of the expression that you came up with in step 4 of this thing. Of x minus 2 squared plus 1 minus 2 over x minus 1. Evaluate this limit. Well, the way we evaluate this limit, you can try plugging in, changing all the x's into 1's, but you'll get 0 over 0. So as we'll see in section 2.3, the trick will be getting rid of this x minus 1 by canceling it with an x minus 1 that's up here but kind of hidden. Can't see it right now, but maybe if you expanded things out, this is equal to the limit as x approaches 1 of x minus 2 squared is x squared minus 4x plus 4. But then I also have this plus 1 and this minus 2. So if I combine like terms, plus 4 and plus 1 gives me plus 5. And minus 2 gives me plus 3. So I get x squared minus 4x plus 3 over x minus 1. And it turns out there's an x minus 1 kind of hidden up in there. There has to be. So we'll find it by factoring. X squared minus 4x plus 3. I'm looking for two numbers that when I multiply them together I get positive 3, and when I add them I get negative 4. Those two numbers are negative 1 and negative 3. And you'll note that I've been writing limit as x approaches 1 as I've gone through here. That's really important for this equal sign, because what I wrote right here is not equal to x minus 3, but the limit of this expression is equal to the limit as x approaches 1 of x minus 3. And I can cross off these x minus 1's as long as I've written limit the whole time. And this is a limit that I can evaluate. 1 minus 3 is equal to negative 2. Negative 2, that sounds familiar. Oh, right, that was my approximation up here. That's awesome. That's good. It's good news that I came up with the same answer. What I just did was I calculated the slope of the tangent line, which it turns out is a really, really important thing to do in calculus. And the way I did it is I used limits and this idea of how the secant line becomes the tangent line as the limit as the 2 points get close together. One approaches the other. I think that I'm done with step 5. Step 6 says use this point and the slope that I just figured out of this blue line, which was negative 2, to come up with the equation of the tangent line. Fine. So for step 6, I got the point at 1, 2, and the slope at negative 2. So there's a few ways you can do this. One way you can do it is point slope form. So y minus y1 equals m times x minus x1. So I got y minus 2 equals negative 2x plus 2. So I got y, if I add 2 to both sides of the equation, equals negative 2x plus 4. So I have a line here that has slope negative 2 and a y-intercept of 4. Note that that's pretty close to what I drew originally in blue here. Right, slope negative 2, yeah, that looks like it has a slope of about negative 2. I mean, it's not great because I just sketched this thing. I guess it should go through this point. And a y-intercept of 4, yeah, it looks like it's pretty close to a y-intercept of 4 here because I just sketched it. It's a little bit low. Should be up here. But reasonably close to my original sketch. Yep, think it is. I think I'm going to call that good.